Welcome again to another one of the videos. This is topic 2, chapter 5, or video B, called data elements, also known as attributes. This is a companion to or a brief summary of chapter 5 of Hoberman's Data Modeling Made Simple. And I'm Dr. Renaud from Shawnee State University. So entities are made up of attributes or data elements. I learned the term attributes when I was a young database programmer, but we can call them data elements, we can call them columns, we can call them attributes. There are lots of different names that we'll see the used to describe them, but they're still basically the same idea. They're the important things about an entity that we need to track. Makes sense. They're identifying marks or identifying things like customer number, student number, social security number. Uh, those would be a part number, serial number, vehicle identification number. They identify something. The ISBN number in a book. You get the idea. The license numbers on things. They identify. They identify the entities. They identify us. So there are other attributes or other data elements within our database and our data systems that describe. For instance, you've got a part. It has a part number that would be identifying. It would have a name. It would maybe have even a field called description. Would your address be, if we have an entity for a human, for a person, name would be, well, describing, could be identifying. Maybe it's a bit of both. There's the person number or ID number that would be identifying, social security number that would be identifying, birthday. Well, birthday would be describing, but it would also be measuring, the third type. But let's look at a part. So we've got a part with a part number, we've got a description of the part, and then we've got maybe its weight, maybe its size, height, width, and depth. Maybe we've got some of its measuring properties. So you can see that these are all important properties that we want to track in our entities. Identifying things, describing things, and measuring attributes. Each attribute needs to be limited to a domain. And a domain is a fancy word for a list of possible values, the domain. So you can think of each attribute as having a ring around it or a set of rules defining what can it be. For instance, domains can be a format. Like, well, it's just an integer. Positive integer, negative integer. You didn't say it's just an integer. Okay, it's a whole number. Fine. It's a float. It's a floating point number. It can be anywhere from negative itty bitty to, positive, great, big, good. It can be a list of characters. For instance, a name might be a format called character 30, which it could be up to 30 characters, 30 letters, 30 symbols long, not 31, but it could be 22 or 12 or whatever. So you could see that it would have a format. And so we can define each data element as having a specific format. Is it a date? Okay, and what's the format of the date? Well, month, day, year, 4-digit month, 2-digit day, 2-digit year, or 2-digit 4-digit year, 2-digit month, 2-digit day. There we go. Maybe we say it's a time, but we define the format. It's a 24-hour time in military time, or it's a time that includes the time zone, which could be a problem because what if we have customers all around the world? We might need to track also not only the time, but the time zone of something. So that would be a format. You could also define the domain of a data element as a list of values. For instance, maybe this attribute is US, state, or territory. So there's a list of 50 some odd 2-letter abbreviations that the post office publishes. That's a domain. That's a list, right? And it has to be one of those, can't be anything else. A domain could also be a range of values. For instance, hire date. Um, hire date would be a range of or could be a range of values because you couldn't have been hired before the company was created. So it would be from um, the day the company started until today, because you can't be hired in the future, and or maybe your birthday. It makes no sense to put an employee's. You've got a database, a data table of your employees. Your business has not been around since the 1850s. And it makes no sense to have an employee with a birth date of in the 1800s. 1900, the person would be 120 plus years old at this point. Yeah, probably not going to be one of my employees at 120 years old. Maybe, um, so you could see that there would be a range. Maybe a range could also be, um, we know that we're tracking student information, and we know that an ACT score is between 8 and 36. The lowest is an 8, the highest is a 36. Okay, well, there we go. It's a range. And once we define the range and once we create the database and model with that range, then our software becomes better because bad, bogus, out of out of domain information can't be put into our database, into our data model. So it's easier to know and it's easier to model if we know the domain up front. Get that information from your customer, get that information up front. And by knowing the domain, documenting the domain, it makes our software better later. So while this is something that's just kind of intuitive almost, it's not intuitive. It's something you need to spend time as you take an entity apart and look at its attributes, look at its data elements, and be sure to understand the domain of each and every one of those data elements. Just one more thing, even though the thank you slide is up. When we're modeling using an entity relationship model, we draw a box, and up at the top we put the name of the entity, and inside the box we list its data elements. We list the names of its attributes, not the values, the names of the attributes. And we'll see that in subsequent slides, subsequent videos. I'd like to say thank you for watching. Remember, this presentation is copyright 2020 by James M. Bruno, PhD. All rights are reserved.